Okay, so welcome to the sixth Quark.net and Azure Meetup. We have Sasha Kovacevic talking about moving refactoring legacy applications to Azure. So you have the floor.
Thank you. Nice to have you. Hello to Cork, and hello to everybody from who joined online from everywhere. So this talk is about refactoring legacy applications to Azure. My name is Sasha. I'm a cloud solution architect. I work for Microsoft, and I'm part of something called the Customer Success Unit. And what we try to do is, we work with Azure's top customers, working on making them more productive and less busy, for example, but just trying to get them to get all the value out of their investment with Azure and with Microsoft that they can get, right? So it's kind of part consulting, part architecture, part development, it's all in there. We're just trying to help. And then, of course, part of my role is also to engage with developers, which was something that's been lacking some time ago by Microsoft, but now we have an awesome guy, Juarez, who's taken over this role, and he's trying to engage more developers to try and get feedback from them and see how they're working and what their needs are. So let's start with just a brief introduction into what this is all going to be about. Well, you've heard all of this digital transformation discussion, right? About realizing true business value from software, but it still remains a challenging proposition, right? So 91% of business leaders see digital transformation as a way of sparking innovation, right? And 85% say they must offer digital services or become irrelevant, right? So going forward, you'll see more and more of this. And we personally believe in Microsoft that developers are the catalysts for digital transformation. Not the only ones, but very a big cog in this machine. And there is something called the Developer Velocity Index that you can check out in a little while. Which just means if the developer velocity index is in the top of the market, then you literally outperform the market. You get your company gets has higher revenue growth and a lot more innovation, right? And so if you want to know more about the developer velocity, you can check this site. Azure.com/developer velocity, and it kind of tries to guide you through collaborate, build, and scale stages of your development. And what you can also do is if you go to developer velocity assessment, you can answer a couple of questions, and you can see where you and your company stand there at this developer velocity index, and it'll tell you what you should be kind of working on if you want to improve. And it's based on what we've seen with our customers. So of course Microsoft has best-in-class tools because they are the #1 driver of business performance, right? And you know them, but the most popular developer tools are Visual Studio Code and Visual Studio, and this is just according to the Stack Overflow survey. But I worked with Eclipse before, as we were discussing just before this call, and I used it for 10 years, but I even then, when I was using it, I kind of wished, if I could switch to Visual Studio, because it seemed a better environment then. So, but Java, Eclipse, it worked well. And part of our, kind of our mission in Microsoft is to empower every person and every organization on the planet to achieve more. So what we want to do is, do that today as well, and try and get you to understand how you would, for example, refactor legacy applications to Azure. So let's take a hypothetical situation, right? So there is a company, there's your company, and you're doing business, and you have 4 large retail customers on your e-commerce platform, and you have a €2 million yearly turnover, right? And it's all happening in Europe. And this is a typical on-premises applications that you have. There's a presentation tier, which with the interface and the data binding and object representation. You have the middle tier, with the things like business logic and data access and common application services, and then you have the data tier with data connections, and then it goes on to the actual database and maybe stored procedures and things you coded directly there. And because this is a .NET the audience, right? I've tried to include the .NET components here and address those, .NET development throughout. But as you know, we support many different languages in Azure. So, and usually the situation is, and I try to go with like one of the worst cases here that we've seen with our customer. There's a presentation tier, middle tier, and data tier, but all of that is deployed on a single VM from an application perspective, and then there's another VM hosting the database, right? And of course, there's also backups because backups are important too. And now let's just try and figure out what's the future, right? So let's say that there is new business requirement today, or as all developers know, yesterday. There's a new retail customer that's joined your company's e-commerce platform, and they have, you've had 2 million turnover before, but now you have 2 billion planned in year one just with this new customer, right? And you need to scale. Well, one of the ways is to use Azure. And just because we're the world's most popular developer toolchain is stays with Microsoft, right? We have GitHub, which is now our property. There's 50 million developers. They're free to do what they want and what they've been doing with GitHub. We're trying to kind of improve their performance. That we have Visual Studio, and there's of course Microsoft Azure as our cloud offering, and then we have something called Power Apps, which helps with, say, citizen developers. With it's a leader in low code, no code development platform. So and if you wandered across the Azure website, you could see there's a lot of services there. Some of them, some people call it a huge Lego box, right? So here are some of them just beautifully represented. You can't really read them, but if you go to the azurecharts.com/overview, you can see them. That's not a Microsoft service, but it provides you with this beautiful view. And if you log into your Azure portal, you can then see hundreds of these services there. And of course the problem then is, how do I use this? How do I advance my application? How do I, use these tiny pieces of services and make my application better? So that's what we're going to try and address today. You can download the Azure SDK, which just allows you to, from a .NET perspective, for example, you can get the SDK and you can use it. There's documentation is, of course, it's all well documented, so you can understand how to use it. But it just abstracts a lot of these libraries. So you don't have to go to the to the lowest common denominator and try and communicate with these services directly. You don't have to implement, in certain cases, things like retry policies and whatnot, because the SDK is all trying to help you there. And these libraries are designed to be consistent and approachable and diagnosable and dependable, just so you can kind of get quickly into it. And once say a library for one service, you can then kind of extrapolate from there for a different service. And then if you want a different view of Azure, there's tools like Visual Studio and Azure DevOps, which help you get the value out of Azure. But then, there's the actual Azure services, and some of them are quite popular with the developer community, like the serverless tools for web and mobile and Kubernetes development. And then, at the bottom, of course, there's always compute, networking, storage, security, and identity that you can also use. So let's begin. We saw the application, how it looks, and how it looks today on premises. But now let's try and make it better in the cloud. So one of the services that we have is the Azure Active Directory, which is basically it's a universal platform to manage and secure identities, right? So what we've seen with our customers is if you use Azure Active Directory, it kind of enables you to do things faster, because it's a platform that is specifically designed for that. And hopefully you're not developing your own identity solutions, right? Because unless you're an identity provider, then it makes no sense. So you should use something off the shelf. And Azure Active Directory for application development is a perfect fit. And you can see here, for example, once you create your project and you import, all the libraries, and you can really quickly, with a few annotations, kind of guide your development. Here you can see how you can, allow anonymous access to some of these methods, and you can, authorize them to maybe be just have a viewer role if you have to do this, and if you maybe have a reader role if you have to do another. But basically, it just simplifies that piece of development. You do have to know a bit about Azure Active Directory, but again, for just application development, you don't need to know that much to get started. You can then, of course, host your domain in Azure, and for outstanding performance availability, because we have this global network of DNS servers, right? And the reason there is you're going to want to map your different, say, APIs and services that you have to DNSs, so that you can use things like load balancers and scale between them in an easy way, and maybe switch between those as you need to. Then there's a service called Azure Front Door, which is, it allows you to be, to have like a scalable and secure entry point for fast delivery of your global applications. Meaning, what you can do in there is you can set up your front end and domains and backend pools, and then routing rules, which allows you to just very simply connect and secure your, well, literally front door, as it says. But what it also allows you, it accelerates your application, because it's globally distributed. So if you're you can have people accessing it all over the world, and it also increases application availability, because you can utilize something called smart health probes, which check which of the backend services are working fine and are working well and are ready for you to use. And you can then have smart auto scaling capabilities behind it, so you can scale up and down, or switch between them as you need to. You can, of course, use URL based routing and redirection and rewrites, but it also allows you to do things like multiple site hosting behind one of these services. You can have a session affinity if you really need to, but the guidance is, of course, to go stateless, and then try and avoid that. Store session somewhere else, and then whichever request gets to whichever backend service, it'll work. You can do things like custom domains and certificate management. You can do TLS termination. You can have a web application firewall rules there, and it's all abstracted for you, because it's one service that allows you to do this. And of course, we support IPv6 and HTTP/2 traffic. Right? And then one of the things that you always need when you have a kind of a public-facing web app, say, or a mobile app, or whatever it is secure and reliable global content delivery and escalation, which allows you to kind of host your static things in the Azure CDN, and then people have access to them at their nearest locations, right? So this is what we have so far, right? So we've set up Azure Active Directory. There's Azure DNS, which you call to resolve, resolve the DNS, and then you go to the Azure Active Directory to authenticate, and then you have the front door and CDN, which are kind of your first points of call or entry into your application. And here, there's not that much for a developer to do, but you just need to be aware that these services exist and you're doing. And then, of course, the Azure Active Directory, you just have to use it, as stated, so you can manage your identities and roles and permissions. One of the services that's then, of course, connected with the CDN is the Azure Blob storage, which is, it's massively scalable, it's secure, and it allows you to, store objects for cloud native workloads, but also archiving. It allows you to access for data lakes. It's high performance computing and things like that, like machine learning as well. So you can store huge amounts of data there for kind of pennies on the dollar, or cents on the euro, I guess. And the idea is, it's very easy to provision. You just store things there and point CDN to it, right? That's not really a major hassle. But the idea is then, because that's connected to CDN, those resources that you've uploaded to Blob storage get propagated across the world. And this box that is showing here, that's one Azure region. So the services that are outside of it are basically they're kind of services that span across regions. So things like Azure Front Door, CDN, DNS, and things like that, right? And then now we're focusing on your particular application in one region. We're going to go into how it's going to be deployed into multiple regions and what you need to do there. But for now, let's just focus on one. One thing we also have is a service called API management, and it's one of my favorite services because it allows you to kind of abstract away the management of APIs. What it does is, it allows you to secure your infrastructure. You can have API keys, you can prevent the denial of service attacks, you can use JSON web tokens and things like that. But it also enables you to have partner ecosystems, or if you have multiple groups of developers who are doing the development, they need to have access to different APIs. You can do this there because you can build different things and have them accessible to different groups of people. You can even do things like throttling and so forth. You can even monetize the APIs, right? So all of that is available. But of course, part of what you can do is running an internal API program, right? So if you have, say, teams of developers that are all doing, say, 15 different applications or 15 different microservices for one application and things like that, you can all, centralize that and allow people to access it. But the main point is you also get a developer portal, right? You have an API gateway, which is going to be used for connections, and the Azure portal, which you can use to configure it. But the developer portal is literally a portal you can log into and manage the APIs, create products and packages, and then say, well, this is a product that everybody can use. This is a product that some of the people can use, and so on. And it's very easy to manage. You don't have to actually code that part. Then what we try to do in the cloud, of course, is decouple services, right? So one of the services you can use for that is a service bus, which allows you, to have a reliable cloud messaging, and you can have hybrid integration, right? So what you would basically just have is, publish a message, and then you, of course, have, different services that can read from it. Another one of those is the Event Hubs, which helps with real-time data ingestion. It can ingest huge amounts of data. So, for example, if you're having an IoT, a device fleet that you're managing, or it doesn't have to be an IoT device. It can be an IoT device, standalone or built into a car or whatever. They can all connect to this, and you can send telemetry. You can ingest huge amounts of data. So now you can already see how this is going to work through your application, right? So you connect from the internet. You go to the DNS and the Active Directory to do the authentication. Then you go to the Azure front door, and then let's say that you are using API management for potentially giving access to other people, and then they can publish messages into your service bus and event hubs, which you can then consume. Or they can then consume. Then what we also have is a service called Azure Functions, which is kind of a serverless compute option. It just allows you to run your code in an easy and simple and quite cost-effective way in the cloud. The reason behind it being that I come from a developer background myself, and what I never really liked is managing infrastructure, right? If I just can deploy my code to run and it runs well in the cloud, then I don't really care where it's what it is running on, right? And in the case of Azure Functions, you can do things like pay per use or provision throughput as you need to. But you can see here a little animation of how this works, because all Azure Functions basically have a trigger and an input and output binding. So what you can say is every time somebody something happens, and these triggers can be all sorts of things like message arrived, or you can even call it directly, right? But it can be on schedule, or there's a message in the queue, there's a file in the blob storage. Whatever happens, you just trigger every time the little mini function spins. It takes that input that you have. Maybe you need to process a file or read a message, and then it just outputs it, and then it kind of dies. The service itself, right? It goes away, and you're not paying for it. So and it scales because it's so tiny. It provisions within milliseconds, and one of our guidances, of course, is you should keep it tiny. But the idea is, let's say you have you're selling something through the website, and usually you have 1 or 2 visitors. Well, then one of these functions can work just fine, but then you suddenly become popular, and then now you need to sell a million of these, right? Or read a million of messages, or whatever the scale is. And then you can do this through the Azure Functions API, because that allows you easy to scale, and you don't really have to do much to get that capability. And just for how you can use it in the consumption mode, so you pay per use. You can use it in a sort of a premium mode where you do provision some sort of infrastructure in the background, but then it's 100% yours, and then you can utilize it, and that's more cost effective. Like if you have an API for, say, ingestion of this telemetry, and it's basically running 24/7, right? So it makes sense to then save cost by provisioning infrastructure. And then you can still use the consumption mode to just burst out. Then you can use you can use this in Kubernetes as well. You can provision it there. You can use it in Azure Stack, which is our offering for on-premises infrastructure management, but kind of like the cloud through the same interface. And then you can use it, of course, use it on the edge. And we of course cater to a lot of these programming languages. The number one being .NET, of course. But we see a lot of use from, say, Node and Java as well, and more Python. And believe it or not, I don't know how familiar you are with these services, but this is an example of an entire function which has a HTTP trigger. Means when somebody calls an HTTP function, there is a get and post events, right? Which means it has to be a get or post event for this to trigger. And then it basically it just does a little bit of logging, and that's it, right? That's a very easy function to do. So, for example, if you're doing a lot of these services that you need to kind of have tiny little amounts of code running, you can do this in an easy way. And literally, this is all you need in the Visual Studio to actually have it run. Another way you can do this instead of writing code is, through Logic Apps, which is, just a quick way to build powerful integration solutions. But the idea is, behind Logic Apps, you can use a sort of a drag and drop interface, which is available on the Azure portal. But you can also use that in your Visual Studio if you wanted to. And of course, in Visual Studio Code, if you can also see the actual code itself, right? So it's kind of all over, depending on how you like to work, you can use it. That makes sense for you. So as you can see now, the arrows point the other way, because we're reading from the service bus for example, from Azure Functions, while the connection came through API management and posted a message to service bus. What we're now doing is we're reading from it. And you can have topics, so you can have multiple readers and things like that. And of course, Logic Apps can be used as well. So if you have, say, a company full of, kind of demands that are coming to you, but they are kind of simple, and they're doable through Logic App drag and drop interface. You can let other parts of the company use them as well. So you're not the only one on the hook to actually develop these. One thing that is always important in the cloud is speed, and how you can get that on the read part of it is using Redis Cache, for example, because it allows you to store things. So for example, if you have a shopping cart, you can store it there, or if you have items that are always available, you can store them there. Or if you have things that are usually would kind of hard code them in maybe in your code, but you can now just have a quick lookup in Redis, right? And this is what's called the cache aside pattern, which means all you have to do is to implement this in your application is, of course, provision the service, and then just it's a key value pair. So what basically you do is you literally just check the cache. If the information is not there, you then go, you say, oh, it's not in cache. Well, then we have to read it directly from the source. But you can then also store that information in the cache. So for the next call, it's available. What you can also do is fill the cache in the background, because that allows you also to do things like, a populate cache or purge cache as you need to. But it's an easy way to add a lot of capability to your application just by using an additional service. Then, of course, there's the old reliable, SQL, and now it comes with a Azure SQL flavor, which is intelligent, scalable, relational, managed database service, which is basically you just say file new database, and that's it. You have it. There's no infrastructure you need to worry yourself with, and it's just there for you, and you can have as many as you like. But then, of course, previously you would say maybe you would put all your data into SQL database because that's what you're used to and that's what you did, and it made sense maybe on premise, but now it makes sense maybe to offload some of the data that you used to store in a relational database that you don't maybe need to store in a relational database because it's not really relational data. You go then to something like a Cosmos DB, which is a NoSQL database. It's fast, and in our case, in Microsoft's case, it comes with a lot of APIs, to allow you to work as you like. And it's the first and only service to offer industry-leading SLAs. It allows us, it has SLAs on availability, read and write latencies, throughput, and consistency, right? And that's very good because you can then we guarantee you what latency is, and you can then reliably use that in your application. It allows a choice of APIs. So if you had something on premises or that you used before, so like MongoDB, you can then just point it to the Cosmos DB because it understands the MongoDB API, while in the background it's still Cosmos DB. And this is one of the marketing views of it. It just gives you how it looks because it's a global database. It can span the world. You can use all these different APIs, and it gives you these guarantees like low latency and comprehensive SLAs. But if you just look at this picture and then go to the Azure portal, it literally gives you that, because you can, once you've provisioned it, you can just literally go in the Azure portal and pick the regions where you want your data replicated. You just click geographically. Well, I want all of the Europe. I want Australia. Of course, there's cost implications. The more but it allows you an easy way to replicate your data, and you can have read regions all over the world and maybe have one write region. You can switch write regions as you like. You can also have multiple write regions. You can do things like manual failover. So for example, if you want to fail to, from one region to another, you can do that. You can set up failover priorities. So that, for example, if Europe fails, for whatever reason, it's not accessible, you can then go to the closest one, say, instead of going to the US, right, or somewhere far away. You can also have patterns like follow the sun, so you can move around and just turn on and off regions as you need to. And just a note here, there is this concept of consistency, right? And what we allow you in the Cosmos DB, you can pick one out of these 5. So for example, you have strong consistency, which is literally it writes to all of the stores before it kind of goes back to you. Then you have the eventual on the other end, which is you write to one and then the rest of them will get populated whenever, right? So for example, if there is if somebody made a purchase, well, it's important for them to be able to read it immediately, but nobody else on the website cares. So it's fine if it in a couple of seconds it actually gets propagated, and then there's everything in between. And one of the good things about this is you can set it up as a kind of a default option on your database documents, right? But what you can also do is you can set it up in the code per whenever you're calling it. So you can say, well, this one I want eventual, and this one I want strong, and you can pick between those two between those 5 options, right? And the idea is, we give developers a lot of options to be able to kind of pick and choose what works for them. Then there's the overwhelming demand that when you have a lot of data, you kind of need to search through it. And there's the Azure Cognitive Search, which is an AI-powered cloud search service, which allows you to and it can be used for, of course, mobile and web app development. But the idea is you just store huge amounts of data and you just query an API and get that data instead of you having to actually implement the actual search. And so you can see now we've reached the end of this path. So that's one of the paths that we've seen used, and that's to go through the API management, and then off the service bus, you do tiny pieces of code in Azure Functions, or you do no code in Logic Apps, and you just write data in and out, and You can search through it. It's a really easy way to kind of make a developer's life easy, because you don't actually have to develop for all of this. You just develop tiny pieces of it and just use the rest as services. But that's of course not the only way to do this, and it's usually not the only way to architect your application. Usually your application will have other points of entry. So one is the Azure Kubernetes service, which is I don't want to say increasingly more popular, because it's very popular already, but it's highly available, secure, and fully managed Kubernetes service in Azure that we provide for you. You can literally use anything that can be used in a Kubernetes. You can use it as well. Here are just some of the options, right? One of them being .NET. And this is how that second path looks. So you could go direct, to API management and do things from there. You can go to API management and then from there to Kubernetes services, or you can allow also direct access to the Kubernetes service, depending on your needs, right? And then you can set up, for example, an Nginx ingress module, and then you go to different microservices, which then, the pattern for microservices is, they should be self-contained, right? So if you have, say, a customer microservice, that microservice should work without any of the other services being online, being running, and things like that, right? Maybe there are some interconnects between them, but in general, it needs to work. So what you also then use is, within this scope of your microservice that you're building, say like a shopping cart, you would then have separate data stores, you would have separate ways to process, you would have separate ways to search, separate ways to do everything from that microservice. And that allows you to scale, because now, let's say you have a microservice that one of the common ways is, it logs an information for an order, and then sends it to notify the customer, whoever needs to be notified. Well, you can then make that a centralized service and use it across your entire portfolio of products, right? So write once and then everybody uses it. What we also, in Microsoft really strive to do is give, teams tools to actually be able to do this in an easy way, right? So one of the services that we provide is a Dev Spaces service, and that literally gives you this. Azure Dev Spaces provides a rapid iterative Kubernetes development experience, but the point is it also allows you to debug and test all the components of your applications with minimum development machine setup, and also without replicating or mocking up dependencies, right? So for example, here you can see usually the path is, the biking share web talks to bikes talks to reservations. But then if you have developers, for example, Susie is working on bikes and John is working on reservations, you can have your own path. You can do, things like dev and test in an easy way, right? Because the service is smart enough that it can map your particular service and then use the rest as they are deployed. So that allows you really fast and really iterative way to kind of work. Also, what we have is a registry of Docker and Docker Container Initiative images, which is just it's a container image repository which is replicated across the world if you need to, so that your container images, when you need to spin them up, for example, are very close to where they need to be actually spun up. So we have a lot of these regions, and you can have your container images there. One other service that is also very important usually is something to use to monitor all of these application paths and flows and services, and Azure Monitor is the perfect way to do this. So it gives you full observability into your application infrastructure and network. The idea being, it gives you these beautiful dashboards, like, it shows you telemetry for your production applications, for example, where you can see where are the calls going, which parts of the applications are responding, what are the speeds that they're responding with, and you can dig deeper into each of those. And of course, you get kind of high-level utilization also on your, say, Kubernetes clusters and things like that, right? So it covers everything from infrastructure to your application as well. which just allows you an easy way to debug this. And this is sort of a loop that we see that developers work within. So for example, there's this inner loop, which is Dev Spaces and the AKS cluster, right? You just test and debug directly there. You have maybe your repos in GitHub. You use GitHub Actions to actually do the deployments. You know, GitHub Actions, for example, goes to the AKS production cluster and deploys things from the Azure Container Registry, which might be Docker images, right? And you can use things like Helm and Terraform to help with this. There is also, of course, the integration with Azure Monitor, which collects all of this logs and analytics and shows you can then get alerts and, you know, be very smart in how you're running your application. One other thing worth mentioning is, of course, as you're developing your applications, you know, usually what you start with is people hard coding secrets, or then, you know, using their own weird ways of managing secrets and storing them. But there is an Azure Key Vault service, which is also a globally replicated service that you can use to safeguard your secrets. And this is a way for you to use it in the application itself. So you can authenticate, you can create a client, and then you can literally save and retrieve secrets from it. And you know, you're kind of running in a way that is secure. So for example, you would do this in your code instead of storing credentials, so then even developers don't see it, and then you can you know, allow them to, you know, push code to production without knowing the actual secrets, right? And you can then do things like we've seen some customers change their keys every second, you know, because that's what they can do, so why not, right? And so this is kind of a complete solution, how say I would architect an application from what was previously on premises, right? There's a lot of these tiny pieces, but, you know, some of them are, you know, just necessary for you to kind of get away from the drudgery of coding or developing pieces of the application that are not business critical for you. And so you can call this a modern application, right? So if you are a developer and this is what you see, well, it might be overwhelming, but let's just quickly go through which pieces you actually have to cater for and which are just kind of out of the box, ready to just assist you. So for example, Azure Active Directory, it is a service that, you know, it's ready for you out of the box. You can, you know, file a new Azure Active Directory if you need to. You can use the Active Directory that your organization is using, you know, depending on the use case. But you do have to cater for it, right? If your application uses Azure Active Directory, you have to do a bit of coding or refactoring to get it to work with you, right? So you can use it. But as I've shown you, it's usually, you know, you just kind of import it, and there's annotations to use and roles to manage. That's it. Then everything else, like the DNS, the Azure Front Door, the Azure CDN, all of that is literally just configurable through the Azure portal. Or you can use, of course, the templates, so that, you know, you can store that as code as well, but it's just infrastructure code. Then, you know, the API management, again, it's one of those that you configure. There's things you can do there. You can access the portals and you can set up your packages and your APIs. But then the first one you actually need to maybe you know, code for in your application is the service bus, right? Because you have to, you know, push messages to it and read messages off of it, right? So you have to know, you know, your topics. You have to, you know, name your topic spaces and things like that, so that you know who reads from what and how. And of course, you can also use event hubs for huge amounts of data to be ingested. And then you code these tiny pieces of code which run in the service called Azure Functions, which, for example, reads from service bus, right? And how you would have it read from a service bus, you could, you know, have again an Azure key, a secret that tells you where to go and what to do, how to get the message off of it, right? So you're secure even within your own application. And then there's the no code, low code way of doing things. You can drag and drop different, you know, out of thousands of connectors, you can make your own little runnable applications and use those. One other thing you also have to cater for is reading from the cache and reading from the databases, right? Because you know, you read from the cache. If it's not there, you have to read from the database and then put it into the cache. If you're not using a mechanism to populate the cache as a code behind action, right? But then, of course, you can use things like Entity Framework for accessing the SQL database, and then the Cosmos database. You can use things like SDKs and just store your JSON payloads there. The beauty of Cosmos DB is it's kind of flexible. There's no requirement for your JSON payloads to be identical. You can just store them in there. For example, say you have a user object and you want to store information about the user, so that's all fine. But then in a couple of months, when you add more information there, you would then, if you're using this in say an Azure SQL, you would have to add a columns just specifically to cater for those things that you've added. But here you would just send the JSON document in there, and it could get saved for you, and then you can just search for it. Another then, what is your then as a developer, another task for you to actually code for is the actual microservices themselves, and then of course the interactions again with all these different services, right? So as we've said before, the microservices need to be decoupled. They need to be self-contained, and so usually this is it's a team effort to work on them, but the microservices themselves are kind of just working independently of each other, and you can deploy different versions of them at the same time. You can upgrade them without, if you plan it correctly, without affecting the rest of the system. And so out of all of these, the only other one you have to cater for is the Azure Key Vault. So if you have code that accesses secrets, this is how you would do it, right? And so you see from all of this, you don't actually have to do as much coding as you would have before if a lot of this was in your domain, right? As a developer. So another thing that we need to just plan for and cater for is the where the application gets deployed and how it scales. So one way to do this is, there's a concept of regions in Azure, and there's a concept of paired regions. So paired regions are basically the regions where we allow you to we give you a guarantee that whatever we are doing to any of the regions, we're not going to do it to the other one in the pair at the same time. So for example, if we need to upgrade or update a SQL management layer, we'll do that first in North Europe, so that in the unlikely case something goes wrong, you can fail over with no issues to say West Europe, because we haven't deployed that yet there, right? And then what you can also do is then geo-replicate to other regions, right? Some of the services like Azure SQL and Cosmos DB come out of the box ready to do this for you, and some of the services you have to kind of plan in advance. For example, API management, it does come out of the box with this, but you have to do a little bit of work to plan for this in your application. And that means literally, we don't want to brag here, but we have a lot of these regions. So you could potentially have your code running in all of these regions near to your customers, and they could all access it in a really easy and a convenient and latency fast way, right? And so what you can also do is, once you have this application, you also want to do some sort of smart and maybe machine learning capability added to your application, right? So you can use things like Azure Databricks and Azure Machine Learning Service, which can then access all of this information and this data and data models and work its magic to it. And then you can, of course, access it through APIs as you deploy it. And you can deploy these services as well in a sort of way that they're kind of abstracted for you. So they're, if you're a developer and somebody has done a service like this, you can literally access it through an API again, right? And then, of course, another thing that you have to cater for is the, now a whole slew or spectrum of places where your application needs to run, right? So it might be a web application, so it runs on the web. It might also need to be a mobile application. It might be running in mixed reality as well. It might be running on things like, devices out there, so like Internet of Things. So you could deploy your application there as well. You can have it connect to social media. You can have it connect to third-party websites. Maybe it's also, say, a Facebook app and things like that. But it all needs to run, and that's what you need to cater for. And so that's it. That's the whole presentation from how, say, I would architect this say hypothetical application that we spoke about at the beginning, and how it would end up working for you, and which parts you would have to cater for as a developer. And then again, as our mission is as Microsoft to empower every person and every organization on the planet to achieve more, we hope that we do this through all of these services, and just through interaction, hopefully with us as well, where you can get more info and figure out, for example, how you would do this with your own application. So thanks, and I'm happy to answer any and all questions that you might have about this or about Azure in general. And I'm part of Microsoft that focuses on Azure, so I can't promise that I know everything from Microsoft side, but I know quite a bit about Azure.
Yeah, I enabled everyone to talk. So if you want to ask any question, just unmute yourself and ask.
Thanks, Sasa, for the wonderful presentation there. The one question I have in my mind, for which I joined the meetup for this, is like I've been working in development field, like software development field, for last 1.5 years, and while I was working, I've have a little interaction with cloud services. But I'm still struggling to I wanted to move toward this cloud technology, but I'm struggling to get a kickstart. So what do you suggest? Like, what should be my way of interacting? Like, how should I achieve an expertise or something in cloud technology?
Yeah, well, so yeah, it's a very broad question. I mean, it's one of those, like, Azure is huge, and you can never know everything. And I know very little, but because it's so huge, right? But so one of the options I would say is, if you get in contact with the organizers of this conference that are on our call, and have me back, we can discuss more in depth, in different parts of it. But what you can also do is, what I do is, for example, when you would, if you would ask me a question, what I would normally do is I would go to docs.microsoft.com and try and find it there. Just because there's there's information for developers and for using APIs, but there's also a lot of information on the high level, how you get it, how you would start. But another thing, what I would say is also there are free free accounts that you can create. So for example, I know that I'm not sure if this is something I should say, but I have quite a few of them, because you can create as many as you like. It doesn't bother Microsoft, it seems. So just create a free account and start spinning things up, turning it on and off, and destroying it, and developing for it, and trying to deploy it. If you fail, well, it doesn't matter, because it's all free, right? You can try it. And another thing, what I would say is focus on little things, right? So what I gave you here is like an overview of huge amounts of these services and everything, like end to end, how the application would look. But for example, if you have your application that maybe it's a 3-tier application and accesses SQL database, well, number one thing I would try is maybe go and create a blank database in the cloud, and then try connecting to it, and then maybe reading from it, right? Things like that. And if you're having, and that's more on the Azure part, but if you're having trouble or understanding, how you would code for certain of these, well, then it's a lot of these kind of, well, I usually use YouTube and docs.microsoft.com to learn and just, follow along, because that's usually the easiest way. And there's also, if you go to, I think, microsoft.com/learn, there's a lot of these modules. So for example, you can say, well, I want to deploy an IaaS, a VM there, right? And it guides you. You even get access to environment where you can try it, right, for free, for as you're going through the tutorial. So I use a lot of those. I'm on it gives you levels and experience and whatnot. So I'm like level 29 or something, and because I use it a lot, because you can never know all of this, right? So you have to try it.
Okay, yeah.
So
Thanks.
hopefully that helps.
Yeah, I think.
I know it's not easy, like, at the beginning to just give it a start, but if you just try little bits and pieces, for example, one is this, SQL, another one might be, just deploy, I've shown you the Azure Functions, right? You can call it from a browser, and, it just returns a value. You can do that. And then you start building more and more on top of it. But if you just try and, it's just overwhelming if you try to go all in, right?
Yeah,
Great, thanks.
Sasha said, and thank you for the vast knowledge and the resources that you talked about. If you go to docs.microsoft.com, you'll find certainly a lot. And I shared the link on the chat window for a program or offer that Microsoft has for several years. That is the Visual Studio Dev Essentials. And with that, you'll have also credits. I think it's 150 US dollars. I'm not sure. And you also have promo for a free trial for LinkedIn Learning and Pluralsight, if I'm not wrong. So I would definitely go look into that and see what you can do from there.
Yeah, and docs.microsoft.com is my first point of call every time. And the docs team, they're my favorite team because they do a wonderful job doing this. Because I would be nowhere without them, right? So I just read a lot there and try and understand it, and maybe even use it.
Any other questions? Seems not. So I have 2 licenses or one license from our sponsor JetBrains to raffle.
Yeah,
I'm leaving myself. Sorry?
Yeah, he sponsors.
Yeah, so Dell is sponsoring us. So they're providing the venue when we have meetings in person, and they are sponsoring also the Zoom that we are using for this webinar. And JetBrains provides 1 year any product you pick license to raffle. So I'm just added here the participants. Sorry, Sasha and myself are going to be out. So it's just among the 5
Let
of
all
you.
the 300 people go.
Yeah, they left to make sure that you have a bigger chance to win something. So I'm just going to pin this. And the winner is Raul.
Congrats.
Congratulations. You're the
Well deserved because
winner.
you were the one brave to ask a question, so very well deserved.
So I'm not going to remove you because this is a different thing. Raul, please get in touch with me either by Meetup or find me on Twitter, and I'll send you the voucher or the coupon to get your license.
Thanks.
And the other thing is we are helping or promoting the .NET Summit 2020. And besides, I sent a communication early. You can get 10%, and we have 100% discount for this event. And we are raffling today. So let's see. Raul tried not to win everything. I'm going to
go Raul.
Spin this
Today
again.
is my lucky day, so I think I should win.
Oh, so close.
So Dave, if you're there, reach out to myself in the same way, either by Meetup or Twitter, and I will make sure that you get your coupon. Okay, our pleasure to have you today, Dave. This session is recorded. I will find a way to make it available and hope to see you soon. We'll have a blockchain talk with Juarez Jr. on the 12th of August, is it? 11th, maybe. So many dates, and I'm getting old. So just checking.
While you're checking, I can say that that must be a great session because I've heard Joris talk before, and well, he's Microsoft, so I'm but I heard him talk, and he's really good
Biased.
with blockchain, like he's
Yeah,
unbelievable.
the
So if you have
intention,
any weird questions for blockchain, come back and ask it.
his intention, and why we postponed this was we were thinking about having the talk and then a small workshop, but because of COVID, so we can't have the workshop. So we're just going to have the talk. So it's August 7 at the same time, 7 p.m. So hope to see you soon, and we'll have more prizes to raffle. And looking forward to hear about you again. Not seeing you because I can see you actually, but having a chat with you. Thank you very much. Thank you, Sasha. It was awesome talk, and I will certainly look at it multiple times, especially when I have any questions or doubts. And hope to see you soon and have one of your lightning talks. Thank you, everyone.
Thank you.
See you soon. Bye-bye.
See you.
Bye bye.
Bye. Bye.
Bye bye. Thank you very much.